All right. Today we're going to be looking at defining general angles and using radian measure. We're going to start by talking about angles in standard position. So in a coordinate plane, an angle can be formed by fixing one ray. That ray is called the initial side. And we're going to rotate the other ray, called the terminal side, about the vertex. Now, how do we decide where to start? Well, we're going to always draw our angles in what's called standard position. And an angle is going to be considered in standard position if its vertex is at the origin and its initial side lies on the positive x-axis. So what you'll see us do today is you'll see us always draw a starting ray on the initial side. You'll see us going in different directions here, different degree measurements, until we hit the terminal side, which we draw this way. So there are three parts to this angle. The initial side, we're going to give a direction, and then where the terminal side is. Now, one thing you might notice is that I went counterclockwise, and that's considered a positive angle. So if we have a positive angle, and I have my fifth hour here with me today, and they're going to take notes with us here. The positive angle, we're going to start at the terminal side, and notice we're going to go in this direction. Okay. So notice that the positive angle is counterclockwise. Do you guys remember how to name quadrants? You guys can talk. Where's the first quadrant? The top right. Where's the second quadrant? Oh, do you see how we're like counting in order of the positive degrees? So 1, 2, 3, 4. I always wondered why they do that, and it's because if we go in that counterclockwise direction, we're really tracing through a positive angle. Okay? Now that being said, there are also negative angles. We're still going to start with our initial side on the positive x-axis, but a negative angle is going to go backwards from where the quadrants were. And so we notice that negative angles actually go clockwise. And so one of the things that we're going to do today is be able to draw an angle in standard position. And so that's what we're going to practice in example 1. Now, first let's just review what how many degrees a whole circle is. How many degrees is a whole circle, a whole rotation? 360. So then half of it is 180, and then each quadrant is 90 degrees, okay? So let's do that to draw 135. I don't need you to bust out a protractor, all right? But I do want us to draw our initial side. And then let's think about what quadrant 135 is going to end up in. What quadrant do you guys think it'll end up in? 2, all right? Where in 2? Close to this, in the middle? In the middle, right? Okay, so we're going to draw our arrow about there to the middle. And then we draw our terminal side. So notice 1, 2, 3 pieces. Do you notice that each of them has an arrow? I don't know if this is showing up. That each of those has an arrow. There's an arrow on the initial side, an arrow on a terminal side, and do you see how there's a directional arrow to tell people which way it turned? Okay? So those are the 3 pieces that we'll have for the angle. Let's do the same thing for 640 degrees. I can draw my initial side. I'm really good at that. And then let's think about what we would need to do for 640. One thing we might notice is that 640 is more than 360 degrees, isn't it? How much extra over 360 is 640? Subtract one more time. 280, okay? If we take 360 plus 280, that gives us that 640. You guys agree with that now that I have it up there? Okay. So how do we encompass this idea that it went a whole 360 degrees and another 280? What we'll do is we'll start on the initial side, And we're going to make one full rotation around like that. But do you see how I ended a little bit past where I started? That tells people that I went 360 degrees. And now I want to go an extra 280, right? So now I'm going to go, so I went 360 around, and now I do an extra 90, 180, 270, and then maybe a little bit more, and then I end there. But do you see the spiral that's here? That spiral is telling people that it didn't just stop here, that it went all the way around and then continued. What one thing am I forgetting? Arrow. Yes, the terminal side arrow, okay? And so that's how we would draw 640, all right, degrees. So now let's graph a negative angle, negative 105. Let me start with my initial side. But this time, because it's a negative angle, we're going to go the opposite direction. And notice that negative 105 is bigger than negative 90, but not quite as big as negative 180. So I'm going to go past that negative 90 a little bit. And then draw my terminal side. Okay? So that's how we draw angles in standard position. Do you guys have any questions on that so far? Okay, very good. All right, so coterminal angles are going to be angles that terminal sides coincide. So that means that, like, if I drew like this angle here, I could also draw this, oops, my pencil exploded here. I could also draw this angle, right? And isn't that coterminal even though it went extra? How much extra is that going, you guys? 360 degrees. And so that's how we're going to find coterminal angles. Coterminal angles can be found by adding and subtracting multiples of 360 degrees from an angle. So in the next example, it wants you to find one positive and one negative angle that are coterminal with the angle. So all we're going to do to this negative 215 is we're just going to add and subtract 360 degrees. So let's take negative 215 and let's add 360 degrees. You can use your calculator. This would be on a calculator part. That's fine. So what would happen if we added 360? Good. We get 145. So we get 145 degrees. So, and that's positive, correct? So now what we can do is negative 215 degrees is negative to begin with, but it wants another negative coterminal angle. So this time, let's subtract 360 degrees. So let's take negative 215 minus 360. And what are you guys getting there? Good, negative 575. So that's one positive and one negative angle that are coterminal. Are those the only angles that are answers? If we added another 360, wouldn't that end up at the same spot? And another 360, and another 360. Likewise, if we kept subtracting 360, wouldn't it end up at the same spot also? So there are a lot of answers, but the answers that we usually give you are the ones that are closest to that angle or closest to something that we wouldn't have a ton of rotations, okay? Let's try another one in letter B. Notice that we have 570 degrees. And so what we want to do is add and subtract multiples of 360. However, do you notice that 570 is already kind of big? So it's true that you could add 360 to 570 and get, what, 930? And you could have that angle. But when an angle is large like this, often the answers that are given are going to be as close to 0 as possible. So if I subtracted 360 degrees from 570, won't that still give me a positive angle? What angle measurement would that give us? 210 degrees, good. So do you see how sometimes subtracting still gives you a positive angle? And again, adding's not wrong. It's just that that would be a lot of spirals. So we're trying to keep it close to 0. So now, what do you think we could do to find a negative angle? Yeah, subtract it one more time. So let's take this 210 that we had, and let's subtract another 360. And so this time if I have 210, and I take another 360 away, I end up with negative 150 degrees. And so that's my positive and negative coterminal angles, okay? Now notice we skipped this D and this C because those aren't in degrees, are they? They're in radians. We'll talk about that in a minute. So I'd like you to practice, though, the idea of drawing an angle and finding one positive and negative coterminal angle in the U try. But which one are we going to skip for right now? C. So skip letter C. And then you guys at home can pause and you can try yourself. Okay, here are the answers that I got for my U try problems. Notice that 65 degrees is in the first quadrant. I have coterminal angles at 425 and negative 295. Okay. Negative 130, notice goes backwards this way into the third quadrant. Coterminal angles were 230 degrees and negative 490. And then letter D, do you guys see that this spirals around once, twice, and then extra? Okay. That's the last one. Coterminal angles, some people might have had 380. That's fine. Why wouldn't 380 and 20 be acceptable as answers for this question? Well, yeah, we need one that's negative, okay? So 380 is fine for your positive, 20 is fine for your positive, but you also have to just keep subtracting until you get a negative then. So I got negative 340. Do you guys notice that each of these has the initial side, the direction, and the terminal side? And I don't know if you can see it, but do you see that all of these have arrows on them? Okay, that direction arrow is important. Are we okay with that? Okay, cool. So I'd like you guys to flip to the back, and we're actually going to jump to this circle real quick. Since we're talking about degrees, before we go into radian land, let's talk about the degrees that are involved in this circle. We said that our initial side is going to be on this positive x-axis. So I'd like us to label, we're going to label these on the inside, okay? I'd like you to label this 0 degrees, because this is actually part of the unit circle that's coming up. Okay, so we're going to try to learn part of it today, or just get exposed to part of it today. We know that a whole trip around the circle is how many degrees? 360 degrees. All right, cool. Then half of that would be 180. So over here we're at 180. And we know that at the quadrants, each of those is 90 degrees. So this would be 90. And then down here we'd have 270. Perfect. Okay? Now, let's split those quadrants in half. If I split the first quadrant in half, this guy right in the middle, where is that going to be? That's going to be 45 degrees. Okay? So 45 degrees to here, another 45 degrees to 90, another 45 degrees would land me at 135 degrees. Another 45 degrees lands me right at that 180. Add another 45 degrees, that gives me 225. Add another 45 degrees, that's 270. Add another 45 degrees, that's 315. Add another 45 degrees, we're at 360. Okay? Now, that covers lots of special right triangles that can lie in any of the quadrants. Because isn't one of the special right triangles a 45, 45, 90 triangle? What's another triangle that was a special right triangle? Yeah, 30, 60, 90. So why don't we count by 30s too? Because those are considered special angles also. So we're going to go here. So this one would be 30 degrees. Add another 30. This one up here would be 60 degrees. Add another 30, we're at 90. Add another 30, we're at 120 degrees. Add another 30, we're at 150 degrees. Add another 30, we're at 180. Add another 30, we're at 210. Next, 240. And then 270. See how you can kind of check if you keep adding and you land on one of the quadrants? Then we add another 30 to make 300. 330, and there we landed at 360, okay? These are special degrees of the unit circle that we are going to eventually be asking you a little bit about. So these are very special angles that as we get more used to them, you'll be able to kind of like tell us right away where 315 is. You'll know that it's right smack dab in the middle of that quadrant 4. That 150 is really close to the axis in quadrant 2, etc. Okay? So I know that you guys have enjoyed degrees, but we're going to move on to something called radian measure. Okay? Now, radian measure is another way that we can measure angles. A radian is defined as the measure of an angle in standard position whose terminal side intercepts an arc of length r, when arc length equals the radius length. Does that make sense? No. Okay, so let me try to draw the picture for you, right? So I want you to pretend that this is a circle, okay? That's the best I can do, all right? And let's say that you have this radius r. If you could take that radius and curve it and like make it equal, so like that all 3 of these things were equal. So do you see how if I flatten this out that it would be the same size as this? So it's almost like an equilateral triangle, except it's not 3 sides, it's 2 sides and an arc, okay? This right here is a radian. That angle measurement is a radian. You know how a degree is like this tiny little, this tiny little thing like this? A radian is this big. And let's say I drew a larger circle and I tried to do the same thing. Do you see that these angles, even though like they're different sized circles, aren't those angles about equal? That angle is the measure of a radian. Okay? Now, usually in Algebra 2, we don't say 2 radians, 5 radians, etc. Let me show you something. If I were to draw radians around this circle, I didn't do a great job, but do you see how there's 1, 2, 3, and a little extra? What special number have we used that's 1, 2, 3, and a little extra in general? Can you guys think of a special number? Pi. Okay? So this is how radians and circles and pi are all melded together like that. It turns out that there are about 3.14 radians in half a circle. So this right here actually measures pi radians. So this is really about 3.14 radians. But for our purposes, we're going to call that pi instead, okay? But a radian is just another unit of measure. You know how like an inch is this big and a foot is this big? A degree is this big and a radian is about that big, okay? It's just a different way to measure angles. Okay, so let's look at how this is going to be related to what we need to do. Do you remember the formula for the circumference of a circle? Good. 2 pi r. So the circumference of a circle is 2 pi r. That means that there are 2 pi radians in a full circle. That's where that formula kind of like gets its credence from. So therefore, if there are 2 pi radians in a full circle, and how many degrees are there in a circle? That means that those are equivalent to each other. That 360 degrees is equivalent to 2 pi radians. Just like 24 inches is equal to 2 feet. Now, we don't usually use that as a conversion factor, do we? What do we use as a conversion factor for feet and inches? 12 inches is 1 foot, right? So do you see how I can divide both of these by 2? So that means that 180 degrees is going to be 1 pi radians. Now, not 1 radian, but 1 pi radians. So remember, when we went through that half a circle there were really 3 radians there. But in Algebra 2, we really do focus on our radians in terms of pi, and we'll practice that today. So first, let's just convert between degrees and radians to degrees. So to go from degrees to radians, you're going to multiply the degree measure by pi over 180 degrees, by pi radians over 180 degrees. That way the degrees cancel. Similarly, to go from radians to degrees, we'll multiply the radian measurement by 180 degrees over pi radians so that those units cancel out. And if you can't remember which one to use, just look at which cancels. But that's the conversion factor. Again, just like 12 inches over 1 foot, the numbers are different, but they mean the same thing, don't they? Just like that's a conversion factor, these are going to be our conversion factor for angles. So example 3 says to convert the degree measure to radians or the radian measure to degrees. So 75 degrees. So what makes the most sense to multiply by? Well, we have degrees in the numerator, so to cancel it, don't I want the degrees in the denominator? So that means that I'm going to multiply by pi over 180. And now the degrees cancel. And now you're going to have 75 pi over 180. Now, what do you think we should do with that? Simplify for sure. Now, you can use your calculator. This would be on the calculator part. But why would it be a bad idea for you to type 75 pi divided by 180 in the calculator? Pi is irrational, isn't it? It's not going to give you a pretty number. So if you're going to use your calculator to simplify, what would you type in? Just 75 over 180. And then you can turn that to a fraction. And you see how it turns into 5/12? Okay. However, our answer isn't 5/12. What do we got to put back in there? The pi. Okay, good. So 5 pi 12ths would be our final answer here. Okay. Letter B, negative 5 pi 4ths. So let's turn this into degrees. So we want to cancel the radians. So that means that the pi part of the radians is going to be in the denominator. And then we have the 180 degrees in the numerator that we want. These cancel. And if I multiply, I'm left with negative 900 degrees over 4. And then I can just divide, and I end up with negative 225 degrees. Do you notice that the radian doesn't have a unit attached to it, but this one does? That's why your geometry teachers got on you to put degrees, because when you're talking about angle measurements and you don't see a unit, guess what the default unit is? The radians, good. So that's why you have to put the degrees on. Okay, letter C, 135. What conversion factor should we multiply by here? Good, pi over 180. Excellent. So the degrees cancel. We're left with 135 pi over 180. And you guys can simplify that either by hand or using the calculator. And what do we end up with here? 3 pi over 4. Wonderful. Okay, last one together, 17 pi 6ths. We're going to multiply by what conversion factor this time? Good, 180 degrees over pi. So these cancel. We end up with 3,060 degrees over 6, which just ends up being 510 degrees. Okay? So that's it. Either 180 degrees over pi or pi radians over 180 degrees. So see if you guys can try E and F. Okay, here are the you try answers. Here I multiplied by pi radians over 180 degrees so that the degrees would cancel. Simplified to get negative 5 pi over 18. Here I multiplied by 180 degrees over pi radians so that I could keep the degree as the unit and cancel out those pi's. And I ended up with 18 degrees. Any clarifications on example 3? All right. One more little example before we talk about how we can graph these angles and radians. This says a record spins at 45 revolutions per minute. Through what angle does a point on the record spin in 1 minute? And it wants our answer in both degrees and radians. Well, look at what it gives us. It gives us 45 revolutions per minute. And it wants to know through what angle a point on the record spins in 1 minute. Well, the key word here is revolution. Let's focus on degrees. How many degrees is one revolution? 360. So couldn't this be a conversion factor? 360 degrees over one revolution? And now you can see that the revolution cancels. And now if you multiply 45 times 360, that gives me 16,200 degrees. And then per minute. So how many degrees does it spin through in 1 minute? 16,000, okay? So basically we'll multiply that by 1 minute. And then we get 16,200 degrees in 1 minute. Now, what if you wanted to do that with radians? You could convert this right away, but let's think about what the conversion factor would be for radians as far as a revolution is concerned. What conversion factor could we use with radians for one full revolution? So what do we say? 2 pi. Awesome, guys. Good. So we could put 2 pi radians for one revolution. The revolutions cancel. And I don't even need a calculator to multiply this. What can we say 45 times 2 pi is? 90 pi. So 90 pi radians in 1 minute. And then again, we only were doing 1 minute, right? So I just multiply that by 1. And I end up with 90 pi. And I'll just write radians here for fun. Okay. But again, if you don't see a unit, it's understood to be radians. So the key word there is the revolution. These are the revolutions, 360 degrees and 2 pi in one revolution. Let's go back to our circle and let's fill out what these special angles would be as far as radians go, okay? So we know that we start at 0, right? And what did we say that a full revolution was? 2 pi. Which means that half of a revolution, so that means going from here all the way to here, would be just 1 pi. Good. So what about going from this part to this part? Half pi. So we usually call that pi over 2. Now, so this is half a pi, a whole pi. Isn't this 1.5 pi? So we usually call that in the unit circle 3 pi over 2. So do you see how if you count, you have 1/2, 2 halves, which is 1, 3 halves, 4 halves, which is 2? Okay. Now let's cut the halves in half. Just like we cut the 90 in half to make the 45. What happens when I cut pi halves in half? What does that become? Pi fourths. So at the 45, let's label that pi fourths. So then 2 pi fourths is really pi halves. Now let's add another pi fourths, and that gives me 3 pi fourths. That's at 135. Another fourth gives me 4 fourths. Isn't 4 fourths the same as pi? Let's keep adding fourths. So I'm at 4 fourths. The next fourths would be 5 fourths. That's going to be at 225 is 5 fourths. 6 fourths is really 3 over 2. Now I have 7 fourths. That doesn't simplify. And 8 fourths, I'm back at 2 pi. So didn't we end up where we wanted to? Now, we also cut the degrees, we cut the 90 into thirds to make 30, 60, 90. What happens when you cut pi halves in thirds? Pi 6, very good. So let's count by pi 6. So 30 degrees is going to be pi 6ths. Now 60 would be 2 pi 6. Now wait a minute. What does 2 pi 6 become? 1/3, right? So we're going to call that pi over 3. Another pi 6 gives me 3 pi 6. Isn't 3/6 the same as 1/2? Okay. Let's add another pi 6. 4/6 really becomes 2/3. So that becomes 2 pi thirds. So that was 4/6. Now this is 5/6. Does that reduce? No. So we'll leave that as 5 pi 6. And then we get to 6/6. What is 6/6? 1. Good. Let's keep counting by 6. Next would be, someone said it, 7/6. Does that reduce? No. So that's 7 pi 6. Next, this would be 8 pi 6, but that reduces to 4 pi over 3. 9/6 is 3 over 2, so 3 pi over 2. 10/6 is really 5 pi over 3. 11/6 doesn't reduce, and 12/6 is 2. And those are the special radian measurements of the unit circle. These will become more familiar with for you over the next couple of days as we work with them. But these are definitely things that you're going to look at. And you will investigate patterns. And we have to flip to the front, so don't put things away yet. Do you notice that the 6 are all real close to the axis? And do you notice that the 4ths are all right in between the axis? We'll investigate those patterns as we go forward, okay? But I'd like us to flip to the front and actually practice graphing with these radians. Let's go back to example 1D. I want us to graph 7 pi 9ths. Well, just like before, let's draw our initial side. Now I want us to think about 7/9. What is that in relation to 1? That's what I really want you guys to think about. That basically, like from right here is 1 pi, and everything over here is more than 1 pi, correct? Okay. So when you think about 7/9, is that more or less than 1 pi? Less, right? So this 1 pi is how many ninths? So like right here, if I went to 1 pi, isn't that 9/9 pi? Do you guys agree with that? Okay. So where would 7/9 be? Pretty close to it, wouldn't it? Would it be closer to this axis or the horizontal axis? A little closer to that one. So that tells you we want to go 7/9 of the way to pi. And then we would draw our end arrow. And that's how we would draw 7 pi 9ths. Okay? Let's jump down real quick. We'll do a wee try. To letter C, where you have 5 pi thirds. Is that more or less than 1? More. And what I like to do is I like to turn ones that are more than 1 into mixed numbers. That really helps me. So what is 5 pi thirds as a mixed number? 1 2/3. Okay? So I'll draw my initial side. And so 1 2/3 means I'm going to be going 1 pi, which is right here, right? And now I want to go not another full pi, but just another 2/3. So where is 2/3 going to end up? In the 4th quadrant. Good. So we're going 1 pi and then 2/3 of a pi way around. Draw my arrow. Draw my terminal side. what if I wanted to graph, sorry, I'm getting excited. What if I wanted to graph like 13 pi 6? What is that as a mixed number? Hang on. 6 goes 2 and 1 6, right? So what I would do in a case like that is I would go 1 pi, 2 pi, and a little bit more. Does that make sense what I mean with the mixed numbers? Yes. All right. I have to do it that way. I'm not going to lie. Okay. One other thing before we go. Remember how we talked about coterminal angles? Well, we need to be able to do that with radians as well. What did we say that 360 was equivalent to? Good. So that means that we can also add and subtract 2 pi, which is what we want to do. By the way, do not turn all radian problems into degrees and then turn it back into, like, don't do that. It's going to be awful for you for the next month if you do that. Honest to gosh. Try to embrace the radians today. Seriously. Don't turn everything into degrees and then back into radians. Deal with the radians, okay? So this 7 pi fourths, what we really want to do is add and subtract 2 pi, but don't we need common denominators to add? Yes. So that means that we want to think about 2 pi as something over 4. So just multiply the denominator by 2. What does that give you? 8. So isn't 8 pi fourths the same as 2 pi? Yes. So we're going to take 7 pi fourths and add 8 pi fourths. That gives me 15 pi fourths. And we're going to take 7 pi fourths and subtract 8 pi fourths. That gives me negative pi fourths. Is that one positive and one negative coterminal angle? Yes. You got it. So then what would we add down here in we try C? If we wanted to deal with this 5/3, if I wanted to add and subtract 2 pi, we would want something over 3, wouldn't we? So how many thirds is 2 pi? We just multiply by 2, and that's 6 pi thirds. So what happens if I take 5/3 plus 6/3? I get 11 pi thirds, and if I subtract, I get negative pi thirds. Thank you. Okay, anyway, like we were saying, if we add 5 pi plus 6 pi thirds, 5/3 pi plus 6/3 pi, we get 11/3 pi. And then if we take 5/3 pi minus 6/3 pi, we get the negative pi thirds. And there's our positive and negative coterminal angle. Okay, hope that helped. Good luck.